Hello guys, very good evening. Welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all the competitive exams. So please join quickly and just mark your presence. I hope I am audible to all of you. Am I audible? Hello Tarun. Good evening. Sahil Malik. Good evening. I hope all of you are doing good. So I hope I am audible and visible to every one of you. Am I audible? Yes. So please quickly join and just say hi or hello. Okay. So in today's session, I am going to discuss about the sliding window protocols. As you know, the sliding window protocols are used in the data link layer. Of course, in transport layer also we use. Basically, it is for the flow control. Control of flow when the sender is faster and the receiver is slower. So before I discuss this flow control techniques and the basics of flow control techniques, so completely I will cover the basics so that you can understand, you can visualize what type of questions can come and all. And for questions separately, I will conduct some sessions. Okay. So please just let me know whether my audio, video, everything is clear. And if you are facing any issue, please let me know. So just you can also just chat in the chat box. You can send the messages in the chat box. Yes, I hope I am audible and visible to every one of you, right? Yes. Now, before I begin the session, let me introduce myself. Myself, Murali Krishna Bukkasamudram. I am having 21 plus years of teaching experience, both in the GATE and also I worked in different engineering colleges. And I am qualified as International Engineering Educator through ISRO certification program. And also I am topper in different NPTEL courses conducted by IITs and also mentored more than 50,000 students across the country in different core areas of computer science. Those are theory of computation TOC, operating systems OS, computer organization COA, computer network CN, digital logic design DLD, information and communication technology ICT. So this is about my brief profile. You can just have a look. And before I begin the session, I request everyone to please do subscribe if you are not yet subscribed it. As we are conducting more classes for NIELIT and GATE fundamentals and also some general sessions we are providing. So for getting benefit of all these things and for getting alerts and all, better you subscribe it so that it will be easy for you, and we will share the links in the Telegram groups. So I think most of you are in my Telegram group. You can just join in my Telegram group so that I will share the class links related to this. And please do like the session and share with your friends if you are really liking it. Yes. Please bring some practice questions as well. Yeah, definitely, Sahil. In the next session, some practice questions also I will definitely bring. But in addition to that, first of all, you have to understand the concepts. So today I have brought some visual content for some animated content I have brought for understanding the sliding window protocol. So I'm sure you will really enjoy this session. So today's the content is little bit different. So in a easily understandable manner. So with animation I brought it. So all of you please be in the session till the end and also inform your friends. You can just share the link of this class with your friends and in all the social media platforms wherever you are. Okay, now let's start the session. And before that, there is a free workshop that is to be conducted on 23rd April. So at 12:30 p.m. By Rakesh Talreja sir. This workshop is related to 6 prime factors to secure the All India rank under the 100 for GATE 2024. Okay, please try to make use of this facility and don't miss this. Please register for this workshop, and this is actually free class only on the YouTube. So free workshop, 6 prime factors to secure the All India rank under 100 in the GATE 2024 by our expert faculty Rakesh Talreja sir. So please try to make use of this facility, and these are our GATE results. Every one of you must be knowing. So GATE 2023, our students have done extremely well, and these are some of our testimonials. We got 62 students under All India rank 50, 13 students under 10, and 107 students under All India rank 100. And these are the some of the toppers. All India rank 5th rank by Dhruv, and All India rank 1st rank by Gautam. All India rank 4th and 5th by Sarv Verma in instrumentation and electrical. And first rank we got in P&I, and 5th rank we got in computer science. So big congratulations to all these people, and I wish you all the best for all the NIELIT aspirants and as well as the GATE 2024 aspirants. Okay, so definitely you will crack it by using if you join any of our courses for GATE or NIELIT or anything. So we are sure we will give a better content, and we will make you to prepare for the tailor-made subjects, right? Now let's start the session. Okay, fine. So before I start the session, you can just have a look at this diagram in computer networks. So sender and receiver are communicating by sending messages through the layers. Every layer at the sender side, headers are being added. At the receiver side, headers are inspected and stripped off, and the message will go to the final destination. So this is how information will flow. And also, if you see the basics of flow control in data link layer, because sliding window protocols are meant for controlling a flow. So when the controlling of flow is required, usually when the sender is faster and the receiver is slow, then in order to stop the sender so that receiver cannot be spammed from the fastness of the sender, so we need to control the flow of sender. So for that, we require to have some protocols. The protocol is nothing but it is the agreed set of rules by both the parties. Okay, yes. And if any sort of doubt, you could ask me immediately. Yes, Alexa, can I get link to Telegram group? Just join now. Okay, definitely I will share. So please bring some practice. Yeah, Sahil, I'll definitely do that. Lenin Singh, is this YouTube live class different from paid? Yeah, paid class is different. This live class is a free class. Okay, it is a free class. Anybody can attend this. Okay, now? Fine. Now, basically, flow control is most important responsibility of the data link layer of the flow control and also error control. So in the data, if there is any error, we need to either correct the error at the receiver side, or we need to ask for the retransmission. And also, flow of data also should be controlled when the sender is fast and receiver is slow. And collectively, these functions are known as the data link protocols. So what are the data link protocols? This flow control and error control are collectively called as data link protocols. So these are the two major activities of data link layer as we discussed. And also, flow control ensures proper flow of data from sender to the receiver, and it is required to control the data flow as a sender and receiver can differ in the speed of data processing. Okay, all the machines may not be in a same speed, so that we need to synchronize the sender and receiver's communication. So that is the reason we require to introduce these flow control mechanisms in the data link layer. Data link layer provides node to node delivery. So from node to node delivery, whenever there is a need for controlling, we have to do that. Okay, yes. Now coming to flow control restriction, it restricts and coordinate number of frames like based on the receiver's buffer space available, based on the receiver's accommodation when the frame is received. The sender can send before it gets acknowledged from the receiver. Okay, so acknowledgement and all, how the sliding window we maintain. So at the sender side how it should be, at the receiver side how it should be, I will explain in detail. Okay, yes. Please try to share with your friends, and do subscribe the channel and share with your friends. And please, now some terminologies we use in the sliding window protocol. Please listen to this slide, then I will go for an animated slide, so that you will understand how sender sliding will be moved and receiver's window will be moved. So frames and acknowledgements are numbered using the sequence numbers basically. So frame sequence number, acknowledgement sequence number. So sequence number is one numerical number assigned for the frames. So frames and acknowledgements are numbered using the sequence number. For instance, if I am using the 2-bit sequence number, using the 2 bits, we can have 00 is one number, 01 one number, 10 one number, 11 one number. So 4 numbers we can have. So each number actually, if you convert into decimal, it is like this. So this is 0001. So this is nothing but 0. This is nothing but 1. this is nothing but 2, this is nothing but 3. Only 4 numbers we can use, 0, 1, 2, 3. But if they have 10 frames, for example, so continuously we repeat the sequence 0, 1, 2, 3 and again 0, 1, 2, 3. Like this, we give the frame sequence number. So first frame 0, second frame 1, third, fourth, fifth frame again 0, sixth frame 1. Like that, repetition of sequence numbers will be there. So for a 2-bit sequence number, frames can be numbered from 0 to 3. Example, 4 frames can be numbered as 0, 1, 2, 3 like this. Okay. Now coming to, let us suppose if you are having 10 frames and with 2-bit sequence number can be numbered like this. So 0, 1 from left to right I am numbering. So 0, 1, 2, 3. Again 0, 1, 2, 3. Total 8 frames are gone. Now 0, 1. So total 10 frames. So this green color indicates somewhere the sliding window is here. Sliding window is nothing but it is a movable window. Only the frames that are available in the window we can transmit at the sender side. Sender side we maintain the send sliding window. Receiver side we maintain receiving sliding window. Okay. So here this example indicates if there are 10 frames with 2-bit sequence number, those can be numbered. So automatically the numbering will be repeated. Hope you are understanding. What do you mean by repetition of numbering? Once if the maximum value is reached, what is the maximum value we can show with 2 bits? 3. Again it will go back to 0. So first and fifth frames are having the same sequence number. Are you following? Yes. Please do share with your friends and please do like this session if you are really liking it. Yes. Fine. Now let us suppose you are having a 3-bit sequence number. Using the 3 bits actually we can have numbers from 0, 0, 0, 0, 0, 1 to 1, 1, 1. So minimum number is 0, maximum number is 7. So 0 to 7. We can have the numbers like this. 0, 1, 2, 3, 4, 5, 6, 7 numbering. So that is for 3-bit sequence number. Frames can be numbered from 0 to 7. Example, 7 frames are numbered like this. If you are having 10 frames, again after 7 again 0, 1, 2, 3 like this it will continue. That is the criteria. I hope everybody understood this. If you have a doubt, you can ask me. Don't hesitate to ask your doubts. Okay now? Yes? Fine. Shall I continue? Okay, fine. Okay. Now, you see this terminology is continued. Let us suppose sender maintains a list of sequence number. Those are called the frame numbers. It is allowed to transmit called the sending window. What is the sender maintenance here? Sender maintains list of sequence numbers. Those are called the frames. I told you, whatever are the frames that are ready to be transmitted, they are available in the window that is called sender's sliding window. So those frames it is allowed to transmit. Those are called sending window. And receiver maintains list of sequence numbers. It is prepared to receive. It is called as receiving window. So we can have a send window as well as receiving window. So sliding means it is a movable. So as and when acknowledgement comes, sender sliding window will be moved. As and when expected frame is arrived correctly without any errors, receiver sliding window will be moved to accommodate the new frames. Okay, that is the criteria here. So I will show you the transactions between sender and receiver, how the window will be moved, what should be the size of the window. That depends on the individual protocols. Yes. Now coming to the sender's window and receiver's window need not have the same lower and upper limits or even have the same size. That depends on the protocol. For stop and wait protocol, send and receive window sizes will be 1. And for go back and it is different. Okay, for select to repeat it's different. Based on the protocol type, so we can use the send sliding window size and receiver's sliding window size. Okay. Coming to a sending window of size n means, that means sender can send all n frames without waiting for acknowledgement. Whatever are available in the sender window, all can be sent without waiting for acknowledgement. Okay. And acknowledgement 3 means it is a cumulative acknowledgement. So up to frame 2 correctly arrived. Say for example 0, 1, 2 frames I sent. ACK 3 means 0, 1, 2 are safe. That is what cumulative acknowledgement is. Okay. So here that point is mentioned. ACK 3 means that receiver has received frame 0 to frame 2 correctly and ready to receive frame 3. Okay. That is the criteria. Now one example I will tell you. So all of you please go through this diagram very carefully Okay, see this, sender and receiver. Okay, so in the sender and receiver, let us assume that we are numbering the frames from 0 to 7 at the sender side, and window size we are maintaining as 4. Let us assume. So how should be the what should be the window size and how we have to select it? That all depends on the type of sliding window protocol we take, whether it is maybe stop and wait protocol, go back and protocol, or select to repeat protocol. Now at this point of time, I wanted to tell you how the window can be moved, okay, using this animated PPT. First, so receiver, for example, frame 0 is expected at the receiver side. Observe carefully. And at the sender side, we are having frames 0, 1, 2, 3. Means all 4 frames can be sent without waiting for acknowledgement. Usually, receiver can send acknowledgement at any time, but receiver gives acknowledgement at the time when receiver also sending one data frame to A. For example, A is communicating with B, B also communicating with A. So if B wanted to give acknowledgement, means it will give acknowledgement along with the next data frame B will send. That is the piggybacking method. So receiver has a freedom to send acknowledgement at any moment. Okay. So please observe this carefully. Now what happens now? So we are having frame 0 sent. Okay. Then frame 0 arrived correctly. That's why. So see the previous one and this one. As and when frame 0 arrived, window is shifted. Which window is shifted? Receiver's window is shifted. Okay. So then why we should send the receiver's window slide? Because 0 is a frame that is expected, that has come without any error. So receiver is expecting frame 1 now. It will accept only when the expected frame is arrived. We have considered a window size of 1 at the receiver in this example. We have considered a window size of 4 at the sender side. Okay, now? Yes. Clear, right? Now, frame 1 is arrived. Sender need not wait for acknowledgement, as I told you. All 4 frames it can send. Okay, after frame 1 is arrived, after it is checked with errors, no errors are found, then it is moved to 2. That means it is next expected frame is 2. Hope you are following this animation. Okay, now coming to, now receiver wanted to give acknowledgement. A2 indicates ACK2. ACK2 means frame 0 is safe, 1 is safe, because acknowledgements are cumulative. So when ACK2 has come, you see the movement of sender window now. Sender window will be slided. 0 and 1 no longer needed in the sliding window because they have sent and they got acknowledged. 0 and 1 are acknowledged. What does it mean? Because ACK2 indicates 0 is safe, 1 is safe. Now, next frames that can be sent without waiting for acknowledgement are frame number 2, 3, 4, 5. All 4 frames can be sent. Okay. Here what I wanted to convey to you is how we can slide the window and at the sender side as well as at the receiver side. If you can understand this clearly, then the individual protocols we can easily understand. That's what introduction is. So how stop and wait will work out, how go back and will work out, all those things definitely I will tell you in a separate session. Okay. Okay. Yes, Jain. Yes. That is, Sahil Malik is asking, sir, the sliding window size less than or equal to 2 power n. That depends on the type of protocol. Either go back n, 2 power n minus 1. If it is select to repeat, 2 power n minus 1. Okay. Just here, I am just letting you know how we can take the sliding of sender window and sliding of receiver window. Only that much you have to understand in the today's class. Okay, so acknowledgement 2 already came. Yes. Now coming to frame 2 is sent. When frame 2 is sent now, frame 2 expected only. So it is correct without any errors. Then receiver has moved to 3. Now frame 3 sent. Receiver moved to 4. 4 expected now. Now after 2 frames again it wanted to send acknowledgement. What ACK will be sent? ACK 4. ACK 4 means up to frame 3 are safe. Now, when ACK 4 is arrived, then what will be the sender window, sliding window? So, 2 and 3 also got acknowledgement. Now, 4, 5, 6, 7 is there. Sender window has been slided because of acknowledgement 4. Now, we can send all the 4 frames, 4th, 5th, 6th and 7th without waiting for acknowledgements. Now, you see, 4, it is expecting 5 now. 5 it is expecting 6, 6 it is expecting 7, 7 then it will go for 0 again, because it will repeat, because 3-bit sequence number we are using. We have used 3-bit sequence number for a frame. So 3 bits means up to maximum 7, because minimum value 0, 0, 0 which is equivalent to 0, maximum value 1, 1, 1 which is equivalent to 7. After that again it will come back to 0. Exactly 4 to 7 it can send. Yes Malik, you are right. Do you have any doubt? And please do share with your friends and do subscribe the channel. And yeah, shall I go to the next slide? Are you okay with this? Some of you please let me know. Yes, great. What happened, Sahil? You got any doubt? Okay, fine. Thank you. Now coming to example 2. In the example 1, what I have shown you, if you observe, sender window size we have taken 4, receiver window size 1. There can be same size also, sender and receiver. So this is applicable for go back and maybe for selective repeat it is like this. Okay, so let us suppose I have taken sender sliding window 4, just assumption, okay, and receiver window size also 4. That means, observe carefully, a receiver can receive any of these 4 frames if it is arrived. If 0 did not come, for example, okay, and 1 will be accepted, 2 will be accepted, if it comes 3 also will be accepted. But in the previous example, I forgot to tell you one thing. In the previous example, let us suppose you go to the first case. Frame 0 not arrived, for example. Then if frame 1 arrived, it will discard. It won't shift the window to right side receiver. And when frame 2 arrived, it will discard. Frame 3 will be discarded. Once if any frame has been arrived with some errors or it is lost somewhere, but still it is expecting that number only. If that number did not arrive, means all other numbers, even if they are arrived 1, 2, 3, they will be discarded. There is a need of retransmitting all the frames again when the time is out. But that is a disadvantage of having only frame sliding window size at the receiver 1. Now if I take okay, you can just observe once again this example, and now I will show you second example, which is much more interesting. So in the second example, you see, sender window size 4 I have taken, receiver window size also 4 I have taken. Even if 0 is lost, 1, 2, 3 can accept, not a problem. And the window will be slided only when frames are arrived in order. If 0 did not arrive, 1, 2, 3 arrived, it will accept, but it won't move the window. But if 0 arrived, it will move it immediately. For instance, you see, for example, frame 0 arrived, no errors, without having any errors it has come. So it will be moved, no issue. And for example, frame 1 is arrived, no errors, it will move. And also frame 2 arrived, no problem, it will move. And frame 3 arrived, no problem, it will move. Like this, because they came in order. If frame 0 last and 1, 2, 3 came, also it will accept, but it won't shift the window. Now all the 4 frames that are available in the sender sliding window has been sent. As of now, no acknowledgement has come, so we did not move the sender sliding window. Hope you are understanding. Is it clear? Any doubt? Yes? Okay, fine. Okay, now coming to acknowledgement. ACK4. What do you mean by ACK4? That means 0, 1, 2, 3 are safe. Yeah, Sahil Malik. If frame 1 is lost, for example, and 0 came, when 0 came, it is shifted, no? Then receiver window will be 1, 2, 3, 4. If 1 is lost, it won't shift from there. Okay. But it will accept other frames which are available in the window. Is it clear? Sahil. Now, acknowledgement 4 is arrived. Now coming to window shifting. Sender window has been slided. Now 4, 5, 6, 7 are expected to be sent. Am I right? Here also, receiver side also. For instance, okay, let us suppose I will show you now. Let us suppose frame 4 I sent. This is lost. Frame 4 is lost. Frame 5 will not be discarded. In the case of previous example, it will discard because only one frame is expected there. So frame 5 will be accepted, and frame 6 will be accepted, and frame 7 will be accepted, 4, 5, 6, 7. All are accepted. But we don't ship the window because fourth frame did not arrive. But instead what we will do is negative acknowledgement we send. NAK with a same number. Negative acknowledgement with a same number. Whatever is expected, no, fourth one. So NAK 4 means only 4 will be retransmitted. There is no need of retransmitting fifth one, sixth one and seventh one. That is advantage of having the window sizes like this. So this type of mechanism used in the select to repeat, and example one mechanism used in the go back n. In a go back n, if any frame is lost, all are discarded. There is need of retransmitting all by going back and all n frames. That's why that name has come like go back n. Okay, now clear? Any doubt, any clarity required, you can ask me. I hope you are enjoying the session. Please share with your friends. Yes. Okay, fine. Now coming to clear, and usually what happens is in a stop and wait protocol, there are three types of protocols here. So I will just write those protocols. One is the stop and wait protocol. Stop and wait ARQ. In a stop and wait ARQ, just I will tell you what are the window sizes you have to choose in every protocol, and we will discuss the problems associated with this separately, and also go back n protocol. So go back n ARQ. ARQ means automatic repeat request. And the third one is selective repeat. Selective repeat. These are the three types of protocols we use in this mechanism. Selective repeat ARQ. So in a stop and wait protocol, actually only we use 1 bit information, that's it. We use only 1 bit frame sequence number. For a stop and wait protocol, 1 bit frame sequence number. That means frame sequence numbers are like 0, 1, 0, 1, 0, 1 and repeat. So first frame 0, second frame numbering is 1, third frame numbering again 0, fourth frame numbering 1, like this it will go. And send window size, receive window size 1 only. Okay, just that outline I am giving you here. In a go back n protocol, n indicates go back n, actually capital N. So small n is the number of bits used for the frame sequence number. So go back n means the number of frames available. This n indicates number of frames available in the window, sliding window as per the selection, not the number of bits used for the frame sequence number. Okay. So for a go back n, actually GBN, just I am writing GBN. So for a go back n, the sender window size should be 2 power n minus 1 and receiver window size is 1. At the receiver side, window size is only 1. The first example is applicable here. For example, n is equal to, for example, 3 bits we are using. So that means the sender window size should be 2 power 3 minus 1. It's a maximum. Sender window size is maximum 2 power n minus 1, where n is the number of bits used for the frame sequence number. Similarly, selective repeat protocol, SRP. Selective repeat protocol. So sender window size is 2 power n minus 1. Receiver window size also 2 power n minus 1. Minus 1 is in the power, not in the base. Here it is in the base. Okay. So that is the selective repeat protocol. Maximum sender window size and maximum receiver window sizes. And if you have any doubt, please ask me. I will try to answer your questions. Yes. Any doubt? So this is some time I will spend to clear the doubts. So please ask your doubts before I conclude the session. So today I just give you outline of what I have taught. So I have told you what is a sliding window protocol, why it is required in the data link layer, and how we can represent the frames using the frame sequence numbers, using some bits, and how it will repeat the frame sequence numbers. And also, what is the movement of sender window and receiver window, sliding windows, based on the acknowledgements arrival, based on the frames arrival. When the sender window will be moved, when the acknowledgement is arrived. When the receiver window will be slided, slide means moving. when the expected frames are arrived correctly without having any errors. Okay, now? So that is the criteria which we make the send and sliding window and receive sliding window. And please try to ask your questions actually in this. So the important things what you have to follow here are the problems related to efficiency of stop and wait protocol, efficiency of go back and protocol, and efficiency of select to repeat protocols. Okay, and also some situation will be given like sender has sent so many frames and some frame numbers, receiver has received so and so, some error has come, and receiver also sent one data frame. After some instance of sequence is given, they will ask what might be the at this point of time what will be the sender window and what frames are present in the sender window. This type of questions usually come on efficiency and also on the situation based transmission of frames. Okay, so please go through the other videos also what I am planning, and day after tomorrow TCP protocol, congestion control protocol will discuss. So try to attend that class also. So thank you so much. Thank you one and all. Still if you have doubt then I will continue. If there is no doubt I will just conclude the session. Okay. Yes. Thank you so much. Thank you one and all. Have a good night. We will meet again day after tomorrow at 7 p.m. with TCP congestion control protocols. Thank you. Thanks a lot.